Let's discuss questions related to numbers. Like there are numbers given to you, need to find probability of even numbers, odd numbers, multiples, not multiples, like that. Let's start. 20 tickets on which numbers are written are mixed thoroughly. Okay, so 20 tickets are there and on which numbers are written. So we'll assume that numbers are written between 1 to 20, remember. And then a ticket is drawn randomly. So you have 20 tickets and numbers written on it, and you are taking that one ticket out of the bunch of it. So we need to find the probability that number on the drawn ticket is a multiple of 3 or 5. So number should be what? Multiple of 3 or multiple of 5. Remember, this is the case where you are dealing with the OR. There are two specifically cases in probability, and an OR. So we are talking about the case of OR. Let's see how to do it. So first of all, we have 20 tickets. So let's label 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and finally 20. So we have 20 tickets. We want to find the probability of getting multiple of 3 or multiple of 5. So let's write multiple of 3. How many do we get it? And another is multiple of 5. Let's see how many do we get. Okay, let's start. So multiples of 3. Multiples of 3, okay, that's 3 itself, then okay, 6 here, then 9, then 12, then 15 and 18. Okay, so let's list down over here: 3, 6, 9, 12, 15 and 18. Okay, so far so good. Next, we want multiples of 5. So it's 5, 10, 15 and 20. So let's write 5, 10, 15 and 20. Now observe, whenever you have this kind of situation, two things we need to talk about: the case of OR. When we take the case of OR, we are supposed to add the outcomes of 3 plus outcomes of 5, multiples of 5. So see, is there any number repeating? Most important case, if the number is being repeated, remember very carefully, right? Okay, so 3 is coming only one time, 6 is one time, 9, 12, but 15 you can see over here I have circled with the both colors, blue and orange as well. In that case, do not count it twice. Okay, remove from any one of the case, any one of it is okay. Don't remove from both of them, that's also incorrect at a time, right? So remove from only one category. So 3, 6, 9, 12, 18 and 5, 10, 15, 20. So how many favorable outcomes are there? That what we are interested in. So let's write favorable outcomes. Favorable outcomes is equal to 1, 2, 3, 4, 5 and 1, 2, 3, 4, 4 and 5. There are 9 favorable outcomes are there. Okay, so let's find the probability. So probability of multiples of 3 or 5. Remember, the interesting thing over here is we are taking the multiples of 3 as well and multiples of 5 as well, because this is the case of OR, multiples of 5 or multiples of 3. So let's see, total number of favorable outcomes are 9. And what is the total number of outcomes? Simple logic, right? We know that it is 20. Don't bother much about it. So that is 20. So this is my final answer. Done? Nothing much to do. So yes, we are going to discuss many other cases. This is just a multiples of 3 and multiples of 5. The interesting thing we learn in this sum is the case of OR. Whenever OR is given, take the favorable outcome of first case, then take the favorable outcome of second case, then see is any outcome is being repeated or not. If it is being repeated, remove from only one category. Don't remove from both categories, right? Then take your favorable outcomes. You have already total number of outcomes. So this is how we solve these sums related to numbers. Let's do another question that is related to numbers only. Let's start with the question. A number is selected at random. Okay, so we are selecting the numbers randomly from 1 to 30. So it is given how many numbers are we supposed to take? 30 numbers, and we are going to start from the 1 to 30 numbers. So let's write here. We have 1 to 30 numbers. We start from 1 and we stop at 30. Find the probability that it is prime number. Now we need to find the probability that it is prime number. Prime number. This is what we are interested in. Okay, so how shall we do that? Let's think about it. Very simple. So before we move, the basic idea of this question is to get the knowledge that do you know what is the prime number, right? So prime numbers are the numbers. Generally I say that it is not present in any table except itself. Like 2, it is not present in any table other than 1. Like 1 2s are 2. That is the only number table it is coming in, right? But let's think about 4. 4 number is coming in table of 2 and table of 4 as well. So 4 is not a prime number. It is composite. We learned this in chapter number 1. Okay. So first of all, we need to list all the prime numbers. So let's list all the prime numbers. Between 1 to 30, not all the prime numbers. It's not possible for us to list. 1 is not a prime number. Okay. Not composite. Remember that. So let's start. 2 is prime. Yes. Then 3, 4 is there. Remember like that. If the number is present in another table, another numbers table, then it is not a prime number. Simply. So 3, then 4, 5. Yes. 6 is there. 7. Yes, 8 is coming, 9 is coming, 10 is coming, 11 it is not coming in any table, 12 is coming, 13 is not coming, right? Then 14 is coming, 15 is coming, 16, then 17, yes. So 17 here, then 18 is coming, and 19, yes. Then 20, 21, 22 and 23, 23 it is, 24, 25, 26, 27, 28, 29. And 30 we know, right? So how many numbers are there? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have 10 prime numbers. So what is the number of favorable outcomes? Number of favorable outcomes are how many? 10. And what is the total number of outcomes? How many numbers do we have? We have 30 numbers. See the question. A number is selected at random from 1 to 30. 1 to 30 में से number लेना है, right? So let's write the final answer. Probability of getting prime number is equal to favorable outcomes over total number of outcomes. Total outcomes. Done. This is the formula. Remember it. Always try to write it. It's good. Favorable outcomes, how many? 10. And total number of outcomes are how many? 30. Now, always remember one thing. If you can reduce the fraction or you can do cancellation, always do it. Right? Your half marks will be cut otherwise. So 0, 0 it's cut and 1 upon 3. Simple. So this is the probability of getting the prime number when we select a number randomly from 1 to 30. Simple. List down all the prime numbers, apply the formula and get the answer. Let's do one more question related to numbers only. Let's read the question. A box contains 90 discs. Okay, so there is a disc, circular one, numbered from 1 to 90. Okay, so here we are going to take 1 to 90 numbers. So far we have taken 30 and previously I think 20 as well. What we need to find? Okay, here if one disc is drawn at random from the box, find the probability that it bears a prime number less than 23. Okay, interesting. So we need to find the probability of prime number it is less than 23. You must be thinking how to get the prime numbers from 1 to 90. Don't bother about that. Till 90, we only need to bother about 23, right? 23 से कम prime number लेने हैं. So let's start again. I think the prime numbers are going to remain same. It's not being changed. So we can use the same information that we used for the previous question. So let's start. 2 is there, 3, 5, 7, 11, then 13, then 17, then 19 and 23. Can we take 23? See, important question. Less than 23 means 23 से कम लेने हैं. 23 नहीं ले सकते हम, right? उससे कम लेने हैं. So we cannot take 23. So how many are there? 1, 2, 3, 4, 5, 6, 7 and 8. So how many outcomes? 8 outcomes are there. Simple. Okay, so let's find the probability. So probability of prime number less than 23. So first of all, we'll take the favorable outcomes over total outcomes, right? So favorable outcomes are 8. Good. And total outcomes, how many are there? 90, right? So 90 it is. Now again, see, 8 and 90 both are prime, both are even numbers, so we can do cancellation here. So here 2 4s are and 2 45s are. I think, can we do cancellation? No. 4 45, no, it will not go. So that's the final answer, 4 by 45. So here the range was bigger, but there was a restriction for choosing that R outcome less than 23, right? So see your question properly, then according to take your steps and find a favorable outcome and get the probability. Let's do one more question related to that. Now here condition is different. So far we dealt with the prime numbers. Here I believe it is perfect square. Let's read the question. A bag contains cards with number written on it from 1 to 80. So we have range from 1 to 80 here. So 1 to 80. That is our range here. Good. What we want to find? Find the probability that a card is pulled out at random. Find the probability that the card shows perfect square. Now we want to find the probability with perfect square. Perfect square. Okay, we want to find the probability of getting perfect square. So perfect square, what's the perfect square? We know very well. 1 into 1, answer we get as a 1. That's a perfect square. 2 into 2, we don't get 2, we get 4, right? So 2 2s are 4. Basically this is the perfect square. 1 square is equal to 1, 2 square is equal to 4. If you keep going. Now till what number shall we go? That is 80. Till 80 we need to go, not beyond that. So next is 9, then 16, then 25. And see, if you don't know, you can just do the square and get the answer. Then 25, then 36, 49, then 64, and 81, and 100. So our numbers are limited to till 80 only. So we need to stop at 64. We cannot take these numbers, right? Because it is 81, we don't have the limit of taking 81 and 110. So perfect square. So how many outcome? 1, 2, 3, 4, 5, 6, 7 and 8. So total 8 outcomes are there. So 8 favorable outcomes are there. What is the total number of outcome? That is 80. So let's find the probability. Probability of getting perfect square. That is favorable outcomes over total number of outcomes. Favorable outcomes are 8, total outcomes are, see, till 80 we need to go. So 80 over here, do the cancellation, 8 1s are, 10s are, and 1 by 10 is my final answer. So probability of getting perfect square from 1 to 80 is 1 upon 10. Let's do something new now. Okay, let's read the question. There are 30 cards of the same size in a bag in which the numbers 1 to 30 written. Okay, so 1 to 30 numbers are there. Okay, so let's start 1 to 30. So 1 to 30 numbers we have it. Good. And one card is taken at randomly from the bag. Okay, find the probability that the number on the selected card is not divisible by 3. Something interesting. Okay, probability that number not divisible by 3. Okay, we need to find the probability that number is not divisible by 3. And what is the range 1 to 30? First of all, can we do one thing, very simple one, that can we get all the numbers which is divisible by 3? Divisible by 3 means what? That if you divide that number by 3, you will get remainder 0. Or like just a basic idea. Let's say you say 27 by 3, that is 9. So 27 is divisible by 3. Simple logic. So let's list out all the numbers that is divisible by 3. Then we'll subtract it. Okay, how? Just wait. So 3 is divisible. Okay. Then 3 is stable, basically we need to write, nothing else. Then 6, then 9, then 12, then 15, then 18, 21, 24, 27, and finally 30. So if you count it, there will be 10 numbers because 3 tens are 30. Obviously there will be 10 numbers. So total number of favorable, oh wait, not favorable exactly. 10 numbers are divisible. There are 10 numbers between 1 to 30 which is divisible by 3. So how many numbers are not divisible? Very interesting point over here. Pay attention carefully that out of 30, 10 number are divisible. So how many are not divisible? That is 30 minus 10, that will be 20 numbers which are not divisible by 3. Understand the logic. What I did, first of all, I have taken all the numbers between 1 to 30 that is divisible by 3. Okay, that is 10, and we know total numbers are 30. So out of 30 I have removed 10. So what's left? 20 only. So there are 20 numbers which are not divisible by 3. So let's go for our answer, that probability of number not divisible by 3. This is what we are interested in, right? So favorable outcomes over total outcomes. So favorable outcomes, is it 10 or 20? Think carefully. That is 20, not 10, because 10 is the number which are divisible and 20 are not divisible. So 20 over 30, 0 0 cancel. So 2 by 3. Very simple question. This is about the divisibility. We need to know how many numbers are divisible by between 1 to 30. Get the number, remove from 30 and get your probability. Let's do sum with the different range. So far we discussed sums that start with the range like 1 to 20, 1 to 30, then 1 to 80, 1 to 90. Now here we have custom range, means like something different than what we dealt with. Okay, so let's start. A box contains card number 11 to 123. Okay, so range, interesting thing. Range is given from 11, yes, 11 to 123. Now let's stop here and understand this case. What is the unique thing over here? How many will be the total number of outcome? Here we cannot directly take 123 because we need to remove 11 cards from this one, right? Or maybe say, let's say 11 cards, right? We are starting from 11. Now see, 123 is the last range we need to go to. We cannot go beyond that. Okay, and we need to start from 11. So basically we are not removing 11 numbers, but we are removing how many numbers? Guess, 10 numbers. Why? Because 11 we are still considering here, right? So till 10 we cannot take it, but from 11 we can take it. So total outcomes will be, right, 123 minus 10, not 11. Remember very carefully, because 11 we still need to take into consideration. So 10 here, 3, 2 minus 1 here, 1 and 1 as well. So most important thing, total number of outcomes. We are supposed to take 113 as the total number of outcomes. Done. Now let's move on to the next one. What we need to do. Okay, so here a card is drawn randomly from the box and find the probability. That's it. Okay, we need to find the probability of getting the perfect square. Interesting. We need to find the probability of perfect square. We need to get the probability of perfect square. Now how many perfect square are between 11 to 123? That's the only our concern. So let's start. Can I say 1, 4, 9 is the perfect square? Yes, they are perfect square, but we cannot take into consideration because we need to start a range from the 11. So 9 is there, after 9 there will be 16. So 16 we can take, 25 we can take, 36, 49, 64, then 81, then 100. And can we take after 100 there will be 11, 121. Yes, 121. Then okay, 1244. That's beyond 123, so we cannot take it. So far so good. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8. 8. So favorable outcomes are how many for this case? That is 8. And total number of outcomes are how many? 113. So let's find the probability of getting the perfect square. So probability of getting perfect square, favorable outcomes are 8 and total number of outcomes are 113. So that's our probability. If we can do cancellation, then go ahead with that, nothing to worry, but I don't believe that we can do cancellation. So that's it, our final answer, right? So probability of getting the perfect square in this case is 8 over 113. Now that was the first case. Sum is not over yet. We have the second case. We have to find the probability of multiple of 7, means that number is being multiplied by 7. Okay, so let's start. 7 ones are 7. Can we take 7? No. Why? Because we need to start from 11. 7 twos are 14. Can we take 14? Yes, we can take it. Okay, so in this manner we are going to find number till 123. So let's start with that. First is 14, then 21. Let's start all the numbers. 28, then 35, then 42, then 49, then 56, then 63, then 70, 77, then 84, 91, then 98, then 905, then if you do 112, then 119. Okay, if you add still, that will be 126, but we cannot take 126. Why? Because 123 is our limit. We cannot go more than that. Okay, now let's find the number of outcomes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. There are 16 multiples of 7 between 11 to 123. Now we know total number of outcomes. How many? 113. How many outcomes are favorable? That is 16. So 16 by 113 is our answer. Simple. Let's write it down. Then we are done with that. Probability of multiple of 7. That is favorable outcomes 16. Total number of outcomes same as the previous one, 113. Again here we cannot do any cancellation, so keep it as it is, no worries. So our two answers are 8 over 113 and the second is okay, finding the probability of perfect square and finding the probability of multiple of 7, that is 16 by 113. Remember, the new thing about this question is we have the different range 11 to 123. So far we had a very simple range, right? So we need to find the total number of outcomes separately. Do not subtract 11 over here. You will get 112. That's absolutely incorrect answer. Okay, you need to subtract 10 because you are removing 10 numbers, not 11 numbers. 11 we are still counting in the range. That's why. So that was it. You find the perfect square, you find the multiples of 7, apply the formula and get the answer.